Example 11, evaluate each sum. All right, so we've got two different series here that we need to basically add up. Something to note about both of them, they're both finite series, okay? We're adding up a countable number of terms in each case, okay? So that means each of these series will converge. Remember what that word means, okay? Converge means you can add it up to a single number. If you have a finite series, it will always converge no matter the type of series you're dealing with. It's infinite that you have to worry about diverging. Okay, so we should be able to add both of these up to get a single number. Okay, all right, let's take a look at the series in part A. We're doing the sum from I equals 1 to 1,000 of the quantity negative I. Okay, so what I would do to start this off, just get an idea of what you're dealing with. Okay, so the terms of this sequence, okay, remember the terms of this sequence are defined by this expression. Okay, we're starting with I equals 1 and we're going all the way up to I equals 1,000. Okay, so we're going to first replace I with 1, so that's going to be negative 1, then bump up the counting number to negative 2, then, or sorry, bump up the counting number to 2, so your term will be negative 2. Bump up your counting number to 3, so your term will be negative 3, and so on. Okay, so these are the terms of the sequence. Okay, and we have to add all of these guys up. Okay, that's what the series notation means. Okay, so how do we go about doing this? Okay, well, the first thing you need to do, the reason I wrote it out, it's really helpful to see how your terms are behaving. You can see that this is arithmetic. Okay, to go from this term to this term, I have to subtract 1. Negative 1 minus 1 gives you negative 2. To go from negative 2 to negative 3, I also subtract 1. Negative 2 minus 1 is negative 3. Okay, so to go from one term to the next, we are subtracting 1. That means our D value is negative 1. Okay, you could also recognize this as arithmetic because the expression that defines the terms of the sequence, it fits the bill of mx plus b. Okay, the m value is negative 1. Okay, x is the variable I, and then the intercept here, the y-intercept would be 0. Okay, so this is an arithmetic series that we're adding up. Okay, so that means you can go and apply one of the formulas on page 6. Okay, so again, we're always trying to choose which formula is the best one to use here. We know enough information to use either one. Okay, we know the first term in the sequence is negative 1. We know the last term in the sequence is negative 1,000. And we know the D value is negative 1 here. Okay, so you can actually use whichever formula you want. Okay, I'll go ahead. It looks like it's going to be easier to use the first formula. It just looks simpler. So I will use Sn is equal to n divided by 2 times A1 plus An. Okay, so I want to add up from 1 to 1,000. We're adding the first 1,000 terms, so n is going to be 1,000 here. Okay, so everywhere you see an n, replace it with 1,000. Okay, we know that A1, like I said, that's the first term in the sequence. Okay, we wrote it out. We know the first term is negative 1. And we know from writing it out, the last term is going to be negative 1,000. Okay, so we just need to figure this out. If we simplify here, this is going to be 500 times negative 1,001. Okay, go to my calculator. Okay, I'm going to get 500 times negative 1,001. Okay, here's the sum. Okay, negative 500,500. Okay, that's the sum of the first 1,000 negative integers. Okay, essentially. Okay. You might be wondering, and I'm going to take a minute to explain this. Okay, There was another way you could have done this problem based on what we learned in section 11.1. Okay, so let me come out to the side here. I'll do this in another color. Okay, in section 11.1, we learned some properties of summation. Okay, we also learned that if you add up the first n many integers, that is equal to n times n plus 2 over 2. Or sorry, I wrote the wrong thing down. N times n plus 1 over 2. Okay, this is something we picked up in 11.1. Okay, I'm going back to those summation properties and rules. Okay, we also learned that if you have a constant in your expression, you can yank it out front, in front of the summation sign. Okay, so if you go back to the summation that we started with, okay, I can yank out the negative sign in front of the sigma notation. And then I would be adding, if you look at just the sigma, I am adding the first 1,000 integers. So we could apply the shortcut here, okay? So if we did this, okay, this would be the negative sign that stays out front, okay? We could replace n with 1,000, so it would be 1,000 times 1,000 plus 1 divided by 2. Okay, so if we go to the calculator and punch this in, we get negative 1,000 times 1,000 plus 1, all divided by 2. We get the same answer. Okay, so maybe you had thoughts of doing this, okay, and the answer is you're completely correct in doing this. Okay, you're just learning more tools. Okay, now we know information about arithmetic series, you know, how to add those guys up. So you're learning multiple ways of doing the same problem. Okay, you can see either way works out for you. Okay, the same thing is going to be true of the series in part B. Okay, we can either use the fact that this is going to be an arithmetic series, or you can use the summation rules and properties that we learned in 11.1. Either way you work it, you should get the same answer. Okay, I'm going to do this one based on the fact that this is arithmetic. Okay, when I look at this summation, okay, I see mx plus b. Okay, I see an m value of -4. X is the k is my index of summation here, and I see a b value of -3. So right off the bat, okay, I know that this is arithmetic. Okay, all right, so that means I can use my formulas that I've learned about adding up, you know, arithmetic series. Okay, there is a twist to this one. If you notice, we don't start at k equals 1. We start at k equals 5. So what do we do about that? Does that matter? Yeah, it matters, because you're adding up, you know, the terms from the 5th term to the 19th term. You can't include the 1st term, the 2nd term, the 3rd term, and the 4th term. So what do? Keep in mind that these formulas we've learned, okay, you have to be adding up the first n many terms of your arithmetic sequence. Using these assumes that you're starting with the first term in your sum. Okay, that's not what's going on here. Okay, we're starting with the 5th term. Okay, so it's going to be a little tricky. Okay, here's what we're going to do. Watch. Okay, we're going to take this sequence and add it up, but a little bit differently. Okay, we're going to go ahead and start at 1. So we're going to add up the terms of the sequence from k equals 1 to k equals 19. Okay, but that's going to include things in the sum that we don't want. Okay, so then we've got to get rid of or subtract out the 1st term, the 2nd term, the 3rd term, and the 4th term. Okay, so, you know, that's just a countable number of terms that you could subtract out individually. But say, you know, you had a different series where you were adding, you know, starting at the 100th term all the way up to the 1000th term. You don't want to subtract out 100 terms individually. Okay, so let's learn how to do this as a whole. Okay, after we add up the first 19 terms, we're going to subtract out the first 4 terms. Okay? I'm doing it this way because both of these new summations start at 1. So I can apply my formula. Okay? All right, so I'm going to calculate 2 different summations and then subtract them. I'm going to put the work for this one in red. I'm going to put the work for this one in green so you can keep track. Okay? All right, so let's get started here. Okay, let's start with the first summation. Okay, I'm doing the sum from k equals 1 to 19 of -3 minus 4k. Okay, this is arithmetic. Again, we have mx plus b. Okay, to sum this up, we are going to apply our formulas. So let's go back to page 6. We need to figure out if we need to use the first or the second. Okay, it's up to you. Okay, we have to figure out a1 regardless. That's needed in both formulas. For this formula, we need the last term. For this formula, we need the d. Okay, so it's up to you. Okay, let me go back here. Okay, first of all, let's figure out a1. Okay, the first term, I need to just plug it in to the expression. So k would be 1 here. Okay, so let me rewrite this to remind you that k would have to be 1 here. That allows us to get a1. Okay, so that's going to be -3 minus 4 times 1. So this is going to be -7. Okay, that's the first term. All right, then we can get the 19th term. We can do the same thing. That way we can use the fourth formula. We can use the first formula if we have the first term and the last term. So let's compute a19 by plugging in k is 19. So this is going to be -3 minus 4 times 19. Okay, I got to go to the calculator for this. -3 minus 4 times 19. Okay, -79 is going to be the 19th term here. Okay. All right. So since we have these 2 pieces of information, okay, we can go plug into this formula. Sn is going to be n divided by 2 times a1 plus an. Okay. Applying this to S19. Okay. Why S19? Because we're summing the first 19 terms of our arithmetic sequence here. All right, so S19 is going to be 19 divided by 2 times -7 plus a -79. Okay, go to the calculator to get this. Okay, we're going to do 19 divided by 2, okay, times -7 minus 79. And here we go. Okay, this first red summation is -817. Okay, that's how we get that. Okay, that is just this part. This is -817. Okay, all right, we need to get the other summation. Okay, the one from 1 to 4. Okay, so we're going to do that in the same way. Before I go there, I do want to point out you could have used the second formula instead of the first formula because you know the d value. The d value is the slope. So if you chose to use the second formula, you would just use a1 and a d value of -4. Okay. All right, so let's change gears and now do the sum from k equals 1 to 4 of -3 minus 4k. Okay. I'm going to do the same thing. Okay, I know what the first term is. Okay, it's going to be this. Nothing's changing here. The first term is still going to be -7. Okay, but now I need to compute the fourth term. Okay, so let's plug in k equals 4. Okay, so that's going to be a4 is going to be -3 minus 4 times 4. So this is going to be -3 minus 16, so that's going to be -19. Okay. All right. So we know the first term, we know the fourth term, so we can apply the first formula again. Okay. But this time, to compute the green summation here, we're adding up the first 4 terms, okay? So we're going to compute S4, the fourth partial sum, plug in 4 for n. Okay, so we're going to get 4 divided by 2 times A1, which is still -7, that has not changed, plus A4. A4 is -19. Okay, so here you go. Okay, we just need to pop this into a calculator. This will give us the other summation. Okay, so here we're going to have 2 times -7 minus 19. So here's the value of the other sigma. It's -52. Okay, so we know the value of the second sigma. Okay, now we're going to be able to compute the overall summation here. Okay, we're going from 1 to 19, getting that value, and then subtracting out the sigma from 1 to 4. Okay, be careful here. We are doing this minus this. Okay, so get your signs right. The answer is going to be -817 minus -52. Okay, so let's go do that. -817 minus a -52. Okay, the value of the overall series here is -765. Okay, so that was a tricky one. Okay, you've got to pay attention to where your summations start. Okay, in order to use those formulas that we know, the summation has to start at 1. So that's why we had to transform this particular summation that we were trying to calculate into 2 different sigmas that started with an index of 1.